Hi, in this video we will go through iGraph case study. iGraph case study consists of graph indexing and querying scheme. There are a couple of available implementations of graph indexing and querying schemes. Gindex, C3, FGindex, 3 plus delta, Gcode, and Swift index. In order to create a new benchmark in Liquid Benchmarks, we have three components which we should take care of them. There are tasks for indexing and querying, and there are some metrics like indexing time, indexing size, and query execution time. And there are two datasets which we are going to run our experiments on them. So now let's have a demo. First, we need to log into Liquid Benchmarks. In Liquid Benchmarks, we can see our domains here. In the last case study, which was about XML compression, we have created a test domain. We will create our new subdomains on the test domain. So right click on test domain and add new subdomain. So one would be indexing. Description is not mandatory, so you can leave it blank or you can put a description later. And we will have another subdomain which is querying. Under indexing, we will put all of our indexing services and algorithms and tasks. And under querying, we will have components related to querying. So let's begin with indexing. Under service schema, we have inputs. So right click on inputs and add new parameter. So the first parameter is operation, and it's text and it's optional. This means all of the services won't have this operation mandatory for them. So some of the algorithms may use operation and the others may not. So we put the tick of optional here. So add them. So we have operation here. Because we have so many input parameters for indexing queries, so I will add all those parameters, and I have to pause the video, and I will come back. No, 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 no. I have to pause the video, and I will come back. No, 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 no. I will add all input parameters, and we will continue from there. So now I have added all of the input parameters as well as one output parameter. So let's add a sample algorithm. So the sample algorithm is C3. The service path is and so we have to choose which input parameter needs to be provided for this algorithm. So all of the optional parameters are listed in here. So the description says the manual of C3 tells me we need operation, dataset file, buffer size, minimum no child vertex, and convert dataset to C3 format. All these 5 are mandatory for these algorithms, so we need to tick them. Click and save. So we have C3. Now let's add another one, which is called Gindex. Here is the pass. So operation, buffer size, query set file URL, pattern mode, and maximum feature size, database file URL, and discriminated ratio. So all these are mandatory. So we have these two. You can add another one if you want. So Gcode, Here is the service path. So only 3 first parameters are mandatory for this G code. So hit on save. We have 3 algorithms in here. So now let's move on to computation environment. We need to create a new computation environment, and so now so the computation environment, I'm gonna just put the title Windows 1 and just choose the basic size, and the image would be ID would be this, and save it. So we have our computation environment. Now let's move on tasks. So now let's create a new task. New task 1. So this task can be private or public. I just leave it as private. So if I'm going to use this task for all of my sample algorithms, I must provide a value for all of the parameters which are ticked in each of the algorithm. So each algorithm needs a couple of specific parameters. So I must know those parameters and provide values. Otherwise, when I'm creating experiments, the system gives me error saying the provided task doesn't have enough information about that specific algorithm. So let's add operation index dataset file URL, buffer size is 100, maximum time 120, and this one would be true. Maximum feature size 0, database file URL, and discriminated ratio 0. So let's save it. Now let's create an experiment. In order to create an experiment, we need at least one output parameter. Let's add these 3 algorithms we have. So we will have 3 algorithms, and a computation environment, and the task. So basically we are expecting to have 3 different experiments because we are going to run our input parameters, which are in task 1, on this Windows machine for 3 different algorithms. So we will have 3 separate experiments. So let's add it to the queue. Add to the queue. I want the results to be public. I can make it private, but I would like to be public so other users can have access to that. In output section, we can see the algorithm is fine, computation environment is detected and fine, task is okay, and other parameter is okay. And I would like to just accept that. So now we are constructing experiments. So it will basically, the system will try to see all of the mandatory parameters must be presented in the task 1 for each of the algorithms as we specified before. So we can see now, okay, all of these 3 algorithms have been generated, experiments have been generated, 3 experiments, and we can see new experiment is added to the queue 159, another one is 160, and the last one is 161. So we can go to previous attempts, and we can see 159, 160, and 161. So all of the status is pending for all of them, and the user is admin user, which is admin user because we are basically logged in using admin user. And the algorithms are Unix, C3, and G code. So, and this process will take some time because Liquid Benchmarks needs to create virtual machines and run the experiments one by one, and then generate the results. So I will pause the video and will continue after finishing the tasks. Now all of the experiments have been finished, and we can see the status is finished. So all of them are done. So basically, if you want to have details of the outputs, we can click on detail in here, and we can see the inputs and outputs. So these are basically inputs and the outputs, and we have all of the parameters which is sent by the virtual machine at that time. And for this experiment we are interested in index building time. So it's for this attempt is when the other attempts we can get the outputs, the different outputs, however they all have index building time. So I do the G-code as well, so it has index building time. So we want to have a comparison between these three algorithms. So I would like to draw a chart. So I select all three of them and draw a chart. I'm interested to draw a chart, pie chart, so I just leave it in pi, and index building time, happy with it, okay, and I have my chart. So in here we can see 87.6% is G-index. So G-index is much slower than the other two algorithms, so we can see the actual number is 92,837 milliseconds, which means 92 seconds. For C3 we have only around 5 seconds, and for G-code is around 8 seconds. So by doing this we can have a good comparison between these three results. We can have another chart, so I draw another chart. I go to column chart this time and check the column chart. So I can see the comparison between the execution time is the index takes much longer than the other two algorithms. If I want to get the PDF, I can download the PDF or CSV file or get the image easily. And basically it's based on task 1. So if I have other tasks as well, they will appear here and I can have more comparison here. I can leave a comment if I want, so I would like to leave a comment, let's say for C3 here. So I just click on comment and leave a comment. So I would say the result is acceptable. So by doing this, all of the other users, if this experiment is public, which is public, all of the other users will have access to see my comment. So I put a comment because I'm admin user, so it comes up with admin user. It says the result is acceptable, so I put this time and date, so I can add another comment or other users can add comments as well. Querying algorithms are very similar to indexing, so we have to define our inputs and sample algorithms and computation environment as well as a task and do the similar action in order to run experiments.